Hi, this is Chintan Patel. In this lecture, we are going to continue our previous session, which was about shear force and bending moment numericals. So we have seen one type of a numericals in the previous lecture that contained a combination of UDL and point load. Now, in this particular lecture, we are going to look at similar kind of examples, but with different loading. So you can see on your diagram that there is a UDL acting on the beam from point C to D, and there is also one free moment which is represented by 6 kilonewton into meter. Now this free moment, or it is also known as the couple. So free moment or couple is applied at the point B. Actually, free moment or couple cannot be applied at a particular point because it is acting on the entire beam. So we cannot just consider it as at one particular point. But for the sake of simplicity, we are taking it as a point B as per our diagram. So what are we going to do? We are going to consider it as direct moment or a simple moment. Then we are not considering it as a shear force. We are considering it as a moment. Then we are going to carry out our simple calculation that we have done in our previous lecture, and using the same method, we are going to draw a shear force and bending moment diagram to complete our example. So first step is to find out the shear force and bending moment reactions. So which are just beam reactions or support reactions. So as you can see on your screen, we have applied a bending moment at point A. So at point A, we need to calculate the bending moment, and you will see that RD is the support reaction at D point. This is RD. This RD is going in the upward direction. That is why it will create anti-clockwise moment, and that is why anti-clockwise moment is taken like this. Another anti-clockwise moment is this free moment. This is our 6 kilonewton into meter, and the direction is represented in your diagram like this. So this arrow indicates that it is going in the anti-clockwise direction. So and we are keeping it simple by taking left hand side as anti-clockwise moment and right hand side as clockwise moments. So on the left hand side we have summed up all the anti-clockwise moment. Now on the right hand side, we need to find out the clockwise moment if there is available in your loading conditions. So you can see that the UDL is always acting in the downward direction. So if you just replace the UDL by the point load, you will see that this point load will create the moment at point A in clockwise direction. So in order to calculate the value of this moment, you need to find out the total load of the UDL first. So the UDL is having the intensity of 3 kilonewton per meter. So for this length of 2 meter, the total UDL will be 3 into 2. So this is the force that is applied due to UDL. We need to find out the moment. Moment can be calculated using force into perpendicular distance. So force into perpendicular distance up to the point A. So you will see that this much is 1 meter, this much is another 1 meter, and this much is another 1 meter up to the half or the midpoint. So the summation of all these values will give you the answer of the distance as 3 meter. That's why we have multiplied 3 distance with the total load of the UDL. Now, if you make the subject RD, then you will get the answer of the reaction at the point D. Putting the value in the relation between RD and RA, you will get the answer of RA as a 3 kilonewton. So this is how we calculate our support reaction. This is our first step, and now we are going to plot our diagram using this. So on your diagram, you can see that at point A, we have represented the value of reaction as 3 kilonewton. that we have calculated just now. And also at the point D, you will get the reaction D as RD. Now, we will calculate the shear force first. So the shear force calculation is over here. As you can see on your screen, we are taking the sign convention like this. So using the same sign convention, we are going to use one imaginary section over here. On the left hand side, there are no other forces, but one force is acting at the point A, that is RA, that will be our shear force at the point A. So 3 kilonewton is our shear force at the point A. Now we will move forward to the point B. At the point B, a free moment is applied, but is there any other shear force acting on the beam? No. That's why we are not considering any force acting on the B point, but we will consider a section, and on the left hand side, one force is acting at the point A. So we are considering this one force in our algebraic sum, and so the one and only force which is acting or causing the shear force at the point B is 3 kilonewton. Now we'll move forward at the point C. If you draw an imaginary section over here and take the left hand side, then in the left hand side again only one force is acting. This is our moment or a couple. This is not a shear force. So we don't have to add or subtract it from the RA value. We don't have to do that. Okay, so we are calculating only shear force. So we need to focus on the shear force only. So 3 kilonewton is the remaining value from the left hand side algebraic sum. Now going forward at the point D, we will take the right hand side. On the right hand side, there are no forces acting on the beam, but one 3 kilonewton force is acting over here. So this 3 kilonewton is considered as negative. So at shear force at the D point is minus 3 kilonewton. So this was the calculation of the shear force. Now we will see how to plot the shear force diagram in our calculations. Now we will start our diagram from the point A with zero value. Here on the reference line, we have represented it as a zero value. At A, we have calculated the value of shear force of 3 kilonewton. So we have represented 3 above the reference line because it is positive. We will carry forward this value up to the point B. As there is no UDL acting between the AB, we are joining these two forces, these 2 points with horizontal line. At B point, there is no addition of the shear force. The value remains the same as 3 kilonewton. So we will move forward up to the C point. At C point also, we are getting the same value of shear force, that is 3 kilonewton. That is why we are representing the value of shear force at C as 3. So up to C point, there is no UDL. That's why we have connected it using the horizontal line. Now what we are going to do, we are going to move forward up to the point D. At point D, we know that the value is negative. So we have to represent it below the reference line. So we have represented 3 below the reference line, or you can also write it as a negative 3 or minus 3. What we are going to do to connect these 2 points, we are going to use one inclined line, because between the point C and D, there is a UDL acting on the beam. And in order to draw the shear force diagram for the UDL section, you have to use an inclined line. So we have connected the point C and D by an inclined line. Now ultimately at the point D, we will close our shear force diagram with the zero value. So this is how the entire shear force diagram is calculated, or we have seen the entire shear force diagram. Now we will calculate the bending moment calculations. So first of all, we are taking two values of the bending moment at point A and point D as 0. Point A and point D 0. For the next point, we are going to move forward up to the point B. So if you take an imaginary section at the point B, we have to take a left hand side only. So on the left hand side, there is one force acting at the point A, that is 3 kilonewton. It is acting in the upward direction, which will cause a clockwise moment at the point B. So the moment at the point B is nothing but 3 into 1. That will give us the answer as the 3 kilonewton, which is positive. That's why we have represented it over here, above the reference line. Then we will move forward at the point B only. At the same point, we are taking a negative or anti-clockwise moment of 6 kilonewton. As it is the anti-clockwise, we have to take it as a negative in our algebraic sum. So in the previous point, there was a 3 kilonewton, and at this point, we are adding minus 6 value. So 3 plus minus 6 will give us the final answer as minus 3 at the point B. So at point B, we are taking the minus answer. That's why it is represented below the reference line like this. Then we will move forward up to the point C. At the point C, we are taking a reference section. On the left hand side, there are two forces. This one is 3 kilonewton, but distance up to C point. Distance up to C point is 2 meter. So 3 into 2 is our final answer for RA. And there is also one free moment. Free moment is nothing but 3 into 2 into 1. That is nothing but our 6, and final answer will be equals to 0. So at C, we are taking the final answer as 0 like this. Now we know that the bending moment diagram is always connected with the inclined line for the sections without UDL. Without UDL. So you will see inclined line like this. After that, we will move forward up to the point D. At point D, we are going to take the moment. We are going to take the moment. But before that, we are going to take a moment at the point E. So at point E, it is nothing but the center point of C and D. So at point E, which is the maximum bending moment of the CD section, can be calculated by taking the reference section like this. Reference sections like this. On the left hand side, there are multiple forces, but on the right hand side, there are two forces acting on the beam. So we are taking the right hand side. On the right hand side, 3 into distance is 1, and UDL is 3 into 2 into this much distance. 3 into 1 into this much distance, that is nothing but 0.5. So 0.5 into 1 into 3, that is our final answer of the bending moment, and we will get the algebraic sum as 1.5 kilonewton into meter. So that 1.5 is represented over here. We know the value of the bending moment at D point is 0. Between C and D, a parabolic curve is used to represent the bending moment diagram. So this is how we complete our example over here. So now we will move forward to the next and the last example of this lecture. This is the example of the cantilever beam. So this is a different type of the beam which we have not studied in the previous examples or the lectures. So that's why I'm introducing this method so that you guys don't get confused whenever it is asked in your examination. So first of all, you need to understand the data that they have given. Draw the shear force and bending moment diagram for the cantilever beam with 4 meter span. What do we mean by the span? Span is the length of the beam. So 4 meter span means the cantilever beam is of 4 meter length. A load of 10 kilonewton is acting at the free end, and 20 kilonewton is acting at the 2 meter from the free end. So you will see that cantilever beam is having one fixed support at the A and one free end at C. So at the free end, we are taking 10 kilonewton, and from this 10 kilonewton up to 2 meter distance, at the 2 meter distance, 20 kilonewton force is also applied. There is also a UDL of 10 kilonewton per meter acting on 2 meter from the fixed end. So from the fixed end is A, there is UDL acting like this. So this is the explanation of the figure, and now we are going to calculate the shear force and bending moment diagram first. So for that, we don't have to calculate the reactions, because we know that the reactions at A point is nothing but the summation of all the downward forces. So the downward forces contains 10 into 2 plus 20 and plus 10. That is nothing but the 50 kilonewton. So we know that the reaction at A point will always be in upward direction of RA equals to 50. RA equals to 50, 50. Now we'll move forward with the SF calculation. So we know that we are starting the value from the 0 at A point, and at A point 50 kilonewton is acting. That's why we have represented a 0 to 50 like this at A point. After that, a UDL is acting, so we will use an incline line. We will use the incline line, but first we need to calculate the shear force at point B. So at point B, we know that we are going to take one section. On the left hand side, 50 upward direction force and UDL downward direction force is acting. UDL value is nothing but 10 into 2, that is 20. So from 50, we are going to subtract 20 to get the final answer as 30. We are going to connect these 2 points with an inclined line. Now calculation of the shear force at the B point. So you will see that at the B point, 10 plus 20 will give us the answer of the 30 kilonewton. Again, at B point, we are adding 20 kilonewton point load like this. This is going in a downward direction. So as it is in the downward direction, we need to subtract it from the final answer. What is the final answer? Final answer is 30 kilonewton. So 30 kilonewton minus 20 will give us the answer of 10 kilonewton. Then we will move forward up to the point C, where our shear force is 10 kilonewton. Shear force is 10 kilonewton. We will join this by a horizontal line, as there is no UDL acting between the B and C. Then we will close our diagram with 0 value at C point. So this was our shear force calculation. Now we will move forward for the bending moment calculation. So at bending moment, we will learn one more thing over here, that at the point C, we will get always a 0 value. So at point C, you will directly taking the value as 0. So here we are going to take the value as 0. But unlike the previous type of the bin, we are not getting the value at A point as 0. So you need to find out the value at A point. So first of all, we are going to calculate the value at B point. Then we will see how to calculate the A point. So at the B point, we are going to take one section, and on the left hand side, there is right hand side, there is only one force which is causing the moment, that is 10 kilonewton. This will give us clockwise direction, but as it is clockwise on the right side, according to sign convention, we need to take it as a negative. So minus 10 into distance 2, this will give us the answer as minus 20 kilonewton. So at point B, we have represented minus 20. As it is minus, that's why we have to represent below the reference line. This is our reference line, below the reference line. Next is point A. So at point A, we will need to find out the moment. So moment can be calculated using the basic formula of algebraic sum of the moment. So the 10 kilonewton is acting at 4 meter distance. So 10 into 4 and 20 into 2 is the distance from the point load at point B up to the point A. Also, there is a UDL. UDL can be calculated by 10 into 2 into distance between the midpoint and A point. The final answer will comes out to be minus 100 kilonewton. So that minus 100 is represented over here. Represented over here. So this is how we finished our bending moment calculation. Before summing up the example or before winding up the lecture, I would like to let you know that all the shear cantilever beam will always have their bending moment diagram negative. So all the values will always be negative. So that's why it will look like this, where parabolic curve for the UDL and inclined line for non-UDL section. So this is how we are going to calculate our examples based on shear force and bending moment. So we keep up to this. Till then, thank you.